A 2 kilogram block of 80 degrees Celsius brass is dropped into 6 kilograms of 20 degrees Celsius water. What is the equilibrium temperature? Specific heat of brass is 4 joules per kg degrees Celsius. The specific heat of water is 8 joules per kg degrees Celsius. The latent heat of fusion for brass is 3 joules per kg. The latent heat of fusion for water is 12 joules per kg. And the melting point of brass is 320 degrees Celsius. Okay. Same thing with this problem whenever we have an equilibrium system. Heat, the change in heat is equal to 0. However, the thing with this is that the object in this scenario does not change its state because brass is brass, it will always stay solid even if it's dropped into water. Therefore, we have only two terms we need to know, which is the specific heat term of brass and B, the specific heat term of water. So how do we find this? It would still go within the realm of Q equals mass times specific heat times change in temperature, but it will be personalized for each instances. So for brass, it's the mass of the brass times the specific heat of brass times the change in temperature of brass. For water, it will be the mass of water times the specific heat of water times the change in temperature of water. Okay, so turn these two into here. Given that Q is equal to this, you add these together and set it to 0. So mass of brass times specific heat of brass times change in temperature of brass plus mass of water times specific heat of water times change in temperature of water equals to 0. Now we plug in what we know. So we know that the mass of the brass is 2 kilograms. We know that the specific heat of brass is 4. The change in temperature of brass, which would be T sub F minus T sub I. Final temperature minus initial temperature is equal to the change in temperature. So we know that the melting point of brass is 320. So, and that the brass is a negative, it is an 80 degrees Celsius piece of brass. So 80 degrees Celsius is just going to be the initial temperature. We don't know what the final temperature is because although it says here that the melting point of brass is at 320 degrees Celsius temperature, it doesn't say that the system reaches that point. Therefore, we are left with T sub F minus 80. Okay, you add it with the mass of the water, which is 6, times specific heat of water, which is 8, times the temperature change of water. You know that the initial temperature of water is a 20 degrees Celsius temperature, but we don't know what the final is, so you do TF minus 20 and you set that to 0. Okay, after that you want to move this for more space, combine like terms. 2 times 4 is 8. T sub f minus 80 plus 6 times 8 is 48. T sub f minus 20 equals 0. So we have 8 T sub f minus 8 times negative 80 should be 8 times negative 80, negative 640 plus 48 T sub f, 48 times a negative 20, you get a 960 equals 0. So you have 8 plus 48, 8 plus 48 is 56. Okay, cross that out. Minus 60 minus 960. No, minus 640 minus 960. And you get forgot the T sub f here. Minus 1600 equals 0. But you can add 1600 to both sides in order to solve for T sub f. So let's erase this for more space. You get 56 T sub f equals 1600 divided by 56 on both sides. You get T sub f equals 1600 divided by 56, which is 28.57. So it's around 28.6 degrees Celsius around. So this is a temperature that reaches equilibrium.